So this is the third video for week 3, and it makes reference to the max patch week3.3.maxpat, which you can download and you can follow along and edit and wreck as much as you want. We're going to cover a couple of really useful objects: the random object, the counter object, the select and the split object. And these are all really useful, essential components of MaxMSP. Let's start with the select object. And in the middle of the patch, you can see the select being used. Now the select object is used for basically, it's like a conditional statement in traditional programming languages. What it basically says is it compares an incoming value with a bunch of options, and essentially is saying, with the argument select 60, 62, 64, is the incoming value equal to 60? If it is, then bang here. Or else, is it equal to 62? Well, if it is, then bang here. Else, if it is equal to 64, bang here. And if it is not else equal to anything else, we'll put the output here. So it's a much faster way of generating sort of conditional structures than having if-else statements. And this is the normal way that these kinds of if-else conditions are represented in MaxMSP. So there can be any number of arguments to a select. You can have 10, 12, 20 different options, and it will simply compare the incoming value to each of those, and if it finds a match, it will bang that particular outlet. And obviously, the more values, more arguments we supply to select, the more outlets there will be. There will always be one more outlet than the number of arguments, because the final outlet is where the result will, the incoming value will go if there is not a match. Okay? So this is simply set up to be my notes coming from my keyboard, and I'm using a strip note to get rid of the note offs, and then I'm saying, is the note that I just played 60? Middle C. Is it 62? A D? Is it 64? An E? Or is it something else? So I will play an E, and you'll see that bang button flashed. And there's a D, and there's a C. Okay? And there's a G. And the G comes out here. Now, not a bang, but the actual value of G, or 64, comes out there. And I've got the strip note in there to get rid of the note offs, because really I just want a single trigger when I put the note down. Now, down below is another sort of conditional object. This is more like is it greater than or equal to 48 and less than or equal to 60? The split has a range, and if the incoming value is within that split, or within that range, including the first and last values, then the message comes out the first outlet, and if it is not in that split, it comes out the second outlet. So it's a way of doing more sort of large conditionals. Is this number between this particular range? So it might be that we want to do something when notes are coming in this octave, and do something else when notes are coming in a different octave. Okay? So the select, very important, and the split, also very useful object. Okay, now the random object. I'm going to make a new random object over here. Whoops, I don't have my pretty colors selected. So I'm going to put a new random in. And random takes one argument. Actually, it can take two arguments, the second being a seed, but we don't need to seed the random number generator unless you really want to. When I type an argument to random, let's say I type 100 as an argument, what the random will do is it will generate a random number between 0 and one less than that argument. So it will a range of 100, but starting at 0. So random 100 will generate values randomly between 0 and 99. So if I put this here, and it takes it produces an integer as its output, and it takes a b bang as its input. So we basically just bang it, and it generates a number for us. 40, 95, and we could keep doing this. And it is random, which means it will duplicate numbers sometimes. Could be all the same number over and over again. That's also random. But it's likely to be any random number within that range. Okay, so pretty easy to use. Now, one of the things we're always doing with random numbers is we're setting the range of values we want, and then we are changing the base of those values, because random will always generate values between 0 and something, but we very often don't want 0 to something. Maybe we want 60 to 72. Let's say, for example, we wanted to generate values. I'm going to put between 60 is the lowest value and 72 is the highest value. I'm thinking we want to generate pitches. Well, what we do is we first say, well, what is the range of values there? And those of you who jump out immediately and say 12 are, of course, wrong. The range is 13. If we want to include 60 and 72, the range would be 13. And then, but we don't want 0 through 12. We actually want to add 60 to the output of this, so that we get a range between 60 and 72. And if I put another number box in, you'll see that I'm now going to get 65, 63, 64, 62, 66, 64, 63, 65, 71. There's my 60. I haven't had 72 yet. Come on. I had 2 61s in a row. I just saw 62. Or sorry, 72. Okay, they're all in there. All right, so that's very often we use those two things together. We calculate what is the range of values we want and what is the base value that we want, and we put the range of values into the random as an argument, and then we add the base value or the lowest value we want to the bottom of that. Good. So there's another object which is called earn, URN, which is unique random number. And the way earn works is it takes one argument like random does, except earn will make sure that all of the numbers are picked before there's any duplicates. And then once it's picked all the numbers, it stops. And that's not always the best thing to do. You have to clear it after it's picked all the numbers. So when it's picked all the numbers, it sends a bang out its second outlet. So you can see this little patch here that I've constructed. In fact, what it does is that when we go through our 12 options and we've exhausted all of them, it will send a bang out here. And what we do is we send a clear message into the earn to basically say we can start over again, and then we send comma, remember that separates messages, we send a bang to generate the number that we just didn't get last time because we were exhausted. So I'm going to start this and we'll say first number is 10, 7, 9, 11, 8, 1, 0, 3. We haven't had a 2 yet. There we go. 6. And now we're duplicating again, going around because we've reset them. Okay, so that's how earn works. So it's random, but it is it is more random in a sense. It's not really more random, but it will give you a better sense of lack of duplication. It'll seem you just won't get nearly as many duplications. You could write sort of serial music with this because it's going to run through all 12 options and then it's going to start again and run through all 12 options. Okay, so that's earn, URN, one argument, which is the range of values, and then you do need to find a way. You just copy this, it works well. If you want to keep it generating over and over again, put a clear comma bang in and attach it in. Okay, so random, earn, we've done the select and the split. Counter. Counter is a very useful object, and I'm going to do the same thing I did here. I'm going to put a counter in here. So we can sort of play around with it. It takes 3 arguments. The first argument is the direction that it goes, 0 being up, 1 being down, 2 being up then down, and then the starting number, let's say 5, and the ending number, 10. It's got lots of inlets, and you can hover over them and see what all the inlets do, and it's got 4 outlets that do various things. You're starting to see that some of these objects can start getting complicated. But the main thing it does is it produces integers when it receives a bang. So a little bit like random. So I'm going to give it a bang. 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. Right? So it's basically going from that minimum to that maximum. If I do put a 1 in here as an argument, it's going down. And if I put a 2 in here as an argument, it will go up to 10 and then down. Okay, every time it gets banged. And you can alter the minimum, maximum values by using the inlets. Good. So that's counter. If you just have counter with no arguments, it counts upwards and it counts from 0 to forever or infinity, or probably not infinity, 2 billion. Okay. Let's look at this patch over here. What I'm doing in this patch is that I am, let's see, I've got a metro running with a toggle box, and the metro is sending out bangs every second, and that metro is generate a random number between 0 and 12, and then I'm using a trigger, and the trigger is, this is very often what you do in Max MSP. You need to do 2 things when you receive a number. One is that we want to take that integer, that value between 0 and 12, and we want to add 48 to it, and we want to make a note and send it to a note out. But we also want to bang the counter, and the counter is simply counting from 0 to 20, and when it reaches 20, the last outlet, it's actually called a carry count, but it will send a bang out when it reaches its maximum. And with that bang, we're going to pass that bang into a number 0, a message 0, and we're going to put that 0 into the metronome to turn it off. So we've created a little loop here where we can turn on this metronome. And when we finished getting 20 notes, or 21 notes, we stopped. Okay. Let's make it run a little faster than this. We've got sort of a strange sound in there. Let's put a program out message on channel 1 and find something a little less dorky sounding. How about a vibraphone? Okay, turn it on. Okay, so we have the little, 12-tone riffs here. Let's put a control structure in here. So rather than turning it off, I'm going to disconnect this. And rather than turning it off when I have reached 20, I'm going to connect up these two. This is generating a 1, and this is generating a 0. So that means that when I play middle C, 60, on my keyboard, it will start this thing going. And when I play D, it'll stop it. So here's C. All right, so this is just a little intro. You're starting to see the interactivity here, where I'm able to use my keyboard using the select to be able to start and stop this process that's going on. You're immediately thinking to yourself, well, how could we make that so that it was working in a particular scale, or how could we make that so that the patches changed? Well, we would just extend on this. So maybe the note E would send the message 11 to the program change. And maybe we want 65 to move that over there, to switch it back to, actually, let's do something else. Let's not switch it back. Let's change the tempo. We'll send the message 100 over here. Let's start it again. That's D, sorry. Alright, so we can just keep adding things to this and make it much, much more complicated. Okay, so that you get the idea. You can see how the select can be extended and altered in all kinds of ways. Okay, so there's just a little simple patch, but I think the main thing there is to introduce some of these objects: the counter object, the metro object, the random object, the earn object, as well as the select and the split. And as I said before, select is the mechanism that is really preferred for doing conditional checks. There is an if-else structure in Max MSP, but it's generally not used, and you'll actually find that rather than having a whole bunch of if-else statements, it's actually more efficient to use select and split objects. So that's all for this video.